Hello guys, welcome back to my new video. In today's video, I'll solve root to leaf paths. First of all, understand this problem through an example. Uh, we know what is root. It is a binary tree. In given, it is a binary tree, and this first one node is root node. Is root node, and the root to path leaf parts, and these all are leaves. What in this problem statement, what we need to do, we need to traverse this binary tree iteratively, and whenever we find any leaf, then we print that path. Okay, now uh, this node 1 is root node, and from this we can how many way we can get to reach this path. This is one way. First four way. First one is 1 2 4. 1 2 4 in this way. This is 1, path 1, and second this one 1 3 7 8 till this end of tree. This is second path, and this is second path 1 3 7 9. Now another way, what is this 1 2 5. 1 2 5. 3 path already we get. Now another path will be, now change the color. Okay, another path will be 1 6 8. Okay, 1 6 8. 1 6 8. And more path can we get? No. Or we traverse all binary tree. We covered full binary tree. How many paths we get? 1 2 3 4. 4 paths we get. Now pseudocode will be function find the root, and we initialize path, then function find the path helper, and we go to current path. Then if node is null, then it will return, and we append the current node value to current path. Okay, now current node is a leaf. Current node is a leaf there, and it add the current path to path list else we recursively find paths left and right subtrees. Is this left and right subtrees. Okay, left right subtrees. Now find paths helper left and right to current path. Then backtrack means we remove the current node from the current path, and it will be current path to pop, and we call the helper function start the root node. So we write down find path the helper root. Okay, then we return paths, and example uses you can see create binary, create function binary, then all paths, we traverse all paths, then find paths. If we find any leaf paths, then for paths we'll print that. I also said if we while traversing, we will, if we find any leaf path, then we'll print that path. Okay, now what is the time complexity of this? Time complexity will be O of remove O of n. It is the time complexity, and space complexity will be O of h. H means height of the tree. Height of the tree. Okay. Now go to code. In pseudocode, we also said we initialize self data, self left, self right. Okay, now we define paths, left, root, optional list, and we initialize path. Then, if find paths, node to current paths. If node is null, I also said node is null, then it will return, and we append the current node to node value to current path. And if current node is leaf node, then it will add current path. Okay, if node is left and node not node right. Yeah, and next we recursively find path left and right subtrees, both sides, and then we remove the current node from the current path. Then it will return path. Now compile and run. Got, now submit. And it's done. We solved today's problem. See you in next video. Still in Tadawai.